Good afternoon and welcome to Griffith Observatory's Tesla coil. This is a device that was invented in the late 19th century by Nikola Tesla. When you see this, you probably think like of Frankenstein movies where they use these. But Nikola Tesla invented this for a different reason. What he wanted to do was to transmit and distribute electricity without using wires. The way that works, as this operates, an electric field will surround this device. If you have a light bulb within that field, that light bulb will receive electricity through the air and will light up. Now on the north side of our exhibit, we do have a multicolored neon sign in the form of Tesla coils that's not plugged into the grid. So as the Tesla coil is engaged, that bulb will light up. Have a look. Well, as you can see, it lit up really nicely, which now you're probably wondering, why do we still have power lines? Well, the reason we still have power lines because as you move away from the Tesla coil, the field drops off rather quickly. Turns out the air is not that very good at conducting electricity. It didn't conduct through the ground, and so it pretty much failed to produce electricity on a large scale. Now at the same time, Edison was using something that was better than this that still had problems though, and it was called direct current. The problem with direct current is it didn't go past 1 mile in the power lines. And so if you were going to use it for a large city, you'd have to have power generating stations every square mile. Those days they burned coal. That would have been a disaster. So Westinghouse worked with alternating current. Now, alternating current is better for a couple of reasons. One, if you can raise the voltage to a high level. Secondly, you could change the voltage. You could drop it down, you could raise it up. So if it gets to the point where you need to go into homes, you can drop it down, and it makes it very, very versatile. Now think of voltage like you would think of a slope on a hill. If you have a shallow slope that's like low voltage, water goes down but not with much force. If you have a steep slope, it goes down with a lot of force. You can send it a lot farther. So if you have a source like Niagara Falls and high voltage alternating current, instead of a square mile, you're powering a good portion of the Northeast. So if there was a war, the currents just didn't last long. It won out very quickly.